Hello everybody, I'm Rick Arends. I'm a Rust developer now for I think 6 years, something like that. So that is really a long time in Rust because it's a relatively new language in that sense. Languages are new if they're younger than 10 years old. Web, mobile, desktop and mixed reality in coding with AI, right? We've been building hold on, let me switch my slides. By the way, my slides are inside my IDE so that I can live code it and write it. So we're building MakePad. What is MakePad? It's an open source Rust UI framework, and it is the IDE and the design tooling around it. And the nice thing about Rust is that you can really start from scratch. You can build your stack on the platform foundations. Just like web browsers are built on the foundations, you can build it straight on the OpenGL or on Metal or on the GPU layer. And you can get real good performance, right? You can get also a very simple build system. Projects using MakePad right now are MakePad Studio. I'm going to show that more during this talk. Also, I have a short video of Rubrix, which is a project at FutureWay. Kevin is building this. He made a small demo video. This is a matrix client written in our UI stack in MakePad with all the styling and all the menus and all the colors and the bits and bobs that you would expect from a browser engine or Flutter or something like that. And it is all working. It's also extremely fast. So I would say this is a very nice proof of function application where you can build, in this sense, a complex application inside a MakePad framework. I don't know, it's very cool. It has all the features that you expect from a desktop system: the tab splitting, emoticons, formatting of text. Animations. Let's see. I have a long time, so I can just let this video play because it is very cool. But yeah, here you see text reflow. You can see it switching back to a mobile form. So the UI also works perfectly well built to mobile. And here it is as a mobile app. So MakePad Framework is our Flutter or React, but built completely in Rust. It has a live design DSL, and it uses Rust, compiled Rust as the application logic. That's very much by choice, because if you write the logic in Rust, you will gain the performance capabilities and the safety of the compiler. So once your code compiles, you generally don't have to worry as much about it crashing at runtime, which is a great feature of Rust. But it is also an adoption problem because you're faced with the compiler issues ahead of time. So you have to solve a lot of edge cases in the code ahead of time. Whereas with JavaScript, you would just get an object is not a function or something like that at runtime, which is unpredictable. So that's a very strong advantage of doing things in Rust. MakePad Studio is our IDE. It is a work in progress. It is a very big project in a sense, right? Like it's like VS Code, but in some sense even more complicated. It has a code editor. Let me give you a tour. Text reflow vertical. It has a code editor with code folding animated. This is one of the effects that I tried to build as founder of Cloud9 IDE, a web-based IDE of a long time ago. And I couldn't do that with web technology, or it was extremely difficult. So, but with Rust, you can just do that. This is our own code editor, so this is not some component that we got somewhere. We have running applications. So here you see the slides, right? So I can open the slides, and this is how I make my slides. I just let's see which page we are. Yeah. So You can just live edit running applications. In this case, I'm live editing the slides viewer. But we can also start. Here's a synthesizer demo that we built a while ago. It's a complete digital synthesizer, polyphonic, a very nice example of how to build applications. I also made a little fractal zoomer. Oh, I think it's, I set it to a very high iteration count, but anyway, it's a fun thing to see. They're all in our repository, these examples. We have an AI chat, which is something that you might have seen from Cursor, where you essentially have a dialogue with the AI as it generates code. I'm going to go into that more later, because this is, of course, an AI conference. So let me go back to my slides. The idea is that the MakePad Studio pulls all of this together. AI workflow, code editor, build systems. I'll show that as well. Like, for instance, you saw the, here's my slides, right? And if I click WebAssembly, I'm going to get my slides in a web browser. Let's see. Oh, it needs to start to compile from scratch, which actually doesn't take that long for us. Rust always gets a bad rep because of the compile time. We put a lot of effort in keeping our compile times down. So here's my slides running in a web browser. Let's see what else. WebAssembly. We can do. Oh, my simple example should run as well. Yeah, there we go. Nice animated shader. I think that's one of the big differentiators of MakePad Framework is that we do everything with the GPU accelerated styling shaders in that sense. So you don't write vector art or you don't do CSS. You write everything in shader programs. And that's actually quite cool for AI as well. So we're trying to pull all this together. What I can show you right now is our visual designer. That's work in progress. I'm working very hard on getting that integrated, but that is essentially our Figma. So you can see how the scope of this project is a little bit large. We have both VS Code and Figma and Cursor that we all need to build. As you saw, MakePad Studio is very live, so all the changes can happen live. So you have, here you have MakePad simple example. Let's close the slides, and then I can open the simple example, and whatever you type, this is like a shader toy. You can just live code everything. You can live code the button text, and you can also live code the Rust, and that works a little bit differently. So here you see the Rust code. Every time I click, it says hi in my log, right? But you can imagine that Rust needs to recompile. So when you change it, you can see that the application goes gray a little bit. But you can also see how fast it still restarts, right? Now it says hello. This is my own workflow also with MakePad Studio. I can show you. Here we have MakePad Simple. And let's see if I can run MakePad Studio as well. I hope it starts up. There we go. Yeah, this is MakePad Studio and MakePad Studio. As you can see, I'm running out of screen space big time. This is why I have an ultra-wide monitor where the whole IDE is just sprayed over the whole wide screen. So this is not really all that great to develop IDEs inside IDEs on very small screens. But this is how I work. This is how I develop the thing in itself. So, live coding in AI. You just saw that the applications that you can run inside MakePad Studio run inside a tab. They run inside a cross-process texture. That's actually quite a lot of annoying platform code you need to deal with on all the platforms that we support, Mac and Windows and Linux. And the live coding is especially great for AI, because AI generates all this code and then you can hot reload and see the application running. So what can AI do with a MakePad application or with Rust, right? It can generate the UIs in the DSL. It can write Rust code actually fairly well. It makes some mistakes sometimes, but the borrow checker sometimes, or some APIs, but it can do it fairly well. And it also seems to understand the APIs that we made for it, right? This is not... apparently, I'm noticing that the cutoff of knowledge for Google Gemini that I'm using in this example is like January. So if I change an API after January, the AI needs to be specially told that it changed. The MakePad codebase is obviously in all of the training sets, which is really great, because then I don't have to spend millions to train my own AI. This is an advantage of being open source. You can just put your code on GitHub, and it will be consumed, unless maybe if you don't have enough stars, but if you have enough stars, it'll be consumed by a lot of AIs, and that means that you can have a better adoption, easier adoption. So what is the workflow that I have been working on? Because I've been working really hard to make a cool working version of what they call vibe coding. By the way, if you say vibe coding to a real programmer, they don't want to be your friends anymore. They're like, oh no, it's one of those AI people. Oh, go away. Especially in the Rust ecosystem, AI has had I don't know, a little bit of a bad reputation. But and to be honest, it is not going to replace me, not yet anyway, but it is definitely a fun party trick. So let's have a look at the workflow that I came up with. So in MakePad, I made AI discussions, let's say AI UI, AI UI 2. I made them files. So these are just file viewers for the different AI conversations. And here I went, please write a calculator application in MakePad, including all the Rust logic implementing the calculator, because I had trouble getting it to do that. Let's start that up. So it made a calculator application. Let me see. I think it made this one. Does it work? No, it doesn't do anything. It doesn't have hovers, and it doesn't do anything. So I was like, hey, AI, this is not what I asked for. So it also makes a lot of errors. So then you say, okay, you try to get it to correct the errors. You can also correct the errors yourself, which I sometimes do as well, because it's faster sometimes to remove one statement than to ask the AI to regenerate the whole thing with that one thing fixed. So I think the rule of vibe coding is that you cannot touch the code, which I think is inefficient. Sometimes you do. So what I did was, because if you do want to touch the code, then the AI gets a little bit desync. I still have to sync it back a little bit. So what I made was I made a second flow, which I call snapshots. Here I don't see the numbers updating when I press a button. Please retry. Did it do that? Oh, now it crashed. Hold on. Oh yeah, these are all non-working examples. This is why I made the snapshots, because sometimes you have to just fix up a few lines of code. But yeah, here we go through the AI. Now it doesn't. I think now it fixed the hovers, right? Now my buttons. You probably can't see that on the screen, but now the hovers light up. And now it actually generated the label as well at the top. Let's see. And now I think it made a working application. And it actually works. The strange thing about AI generating these applications is that if you ask it for the logic of the implementation of the calculator, it does it differently every single time. Like it completely reimagines how to add two numbers together. Sometimes it uses a string, sometimes it uses a set of enums to represent things. Maybe I just need to give it more constraints, but yeah, so now you can also see how easy it is to work with snapshots with the AI flow. Because I find it, if you generate a lot of applications, it's just like AI images, right? It's not like you spent 2 days painting one picture in Photoshop. No, you get 500 thrown at you by the AI. So for code and UI exploration, I also believe that there needs to be some kind of thing like this where you can actually quickly fix and iterate and then make a snapshot of a state of the application so that you can later go back to it and go, no, I think I preferred this one. Or no, maybe I like this one better. You know, it works like that. But I was still very impressed that the AI was able, let me see what the code looks like. I haven't actually looked at it. That's also a rule of vibe coding. You should not look at the code. I don't know. It's kind of nice if you also see what it's doing. See, it's still making some errors. These properties just don't exist. It's just making them up. It did make pretty good buttons. So this is our DSL with the pixel shader styling in there. This looks almost like a well-known other calculator application. So that means that the AI was perfectly capable of generating shader styling, which is kind of neat because we're probably the only ones that are doing it this way, and yet it did that. Also, it one-shotted pretty much a complete structure with the way we do styling with inheritance, right? It has been trained on millions of lines of CSS, but this is not CSS, this is our own DSL. So it figured that out. I was very impressed with that. Of course, it's still just a calculator, so that's kind of boring. So I wanted to make something more visual as well. So I made a small game, or I didn't make a game, the AI made a game. And it's actually better at making games than at making more complex applications. But also this is where the pictures are even more fun. So I started with this. I gave it essentially an empty file with just a way to draw some blocks. And I didn't tell it anything else, just how to draw the blocks and how to get the key presses. And then I said, please make me a snake. And then I go, oh, the snake isn't moving anymore. Please, the snake isn't moving, please fix it. So, okay, here we go. It fixed the game. It even made that it has a tail, which fades out by the length of it. Well, that was also a requirement. And then I was like, well, this snake is kind of boring, right? The squares. Let's make it prettier. So I was like, maybe you can draw the snake as little balls or tubes, because it has to do a shader for that. And here you can see that indeed the AI is drawing them as little circles, but that doesn't really work well yet. And also I'm getting very tired of playing snake. I just want it to run so that I can play with it. So I told it, please make snake work automatically. And it one-shotted an auto-playing snake game. So now I didn't have to bother about playing the game anymore. And I could just focus on asking it to make it prettier. So I'm not a designer, by the way, so it probably looks very ugly to many designers. And I do have trouble getting very pretty things out of the AI. I was impressed by that calculator looking so neat. So then I was like, can't you make the snake out of little blocks that have 3D embossing, right? Because why not? It's a shader. You can do that. And why not give it like a plasma background? Because also that is easy. That is a shader. I didn't really like this one. It's a bit a boring one. So I asked it for a prettier one. And then I asked it to draw its tail better, right? Like I wanted to have a shiny tube that is just well connected at the edges. When the snake is moving around, I wanted to get the AI to do the edges correctly. And I told it, so why don't you make a tube and then rotate and then pass in the rotation so that you can do the corners correctly. And this was its first attempt. As you can see, the rotation of the snake tail is completely off. It is not the way it is, so it should be. So then you go, it's wrong. Could you please fix that? Also, I'll always say please and thank you, because we don't know if these things are sentient, so might as well, right? So here we have now almost a tail that rotates, except at the corners it's not nice 45 degrees. So here we go. More asking it. And by the way, at this time, the AI is starting to generate all these data structures to pass data through to the shader and pretty much one shot correctly. As you can see, the corners as the snake moves around are now correct. Now I wanted to have a more fun effect when you got the candy, or the food as it is in the snake. I wanted to make it flash, like flash, and then do something like that. But because the game was implemented with a tick system, the frame rate is kind of low, right? You can see it like, this is not pretty. Let's get it to do it better. So I gave it one more chance. And it's better now. It doesn't zoom in an awkward way, but it's still low frame rate. So I told the AI, look, if you want to run this at a proper frame rate, you should take it out of the tick loop and run it in the main draw loop. And it flawlessly did that in one shot, and now it was like pretty. So, and then I did something where I'm like, okay, let's see, because all of this history goes in the context window of the AI, right? So sometimes you get cumulative errors where it goes, where the old code that was kind of wrong starts to get amplified further down the line. So you wanna keep this thing sanitized. So then I asked it, okay, go make me Pong now within the same framework, just throw everything out and just make me Pong. And it had a lot of trouble with that. Like it started messing up some includes at the top. So I had to fix this up, but it was only literally 5 lines of code that I had to replace with what it should be. But it is a limitation I have found so far, that if the context window gets too large, somehow you get lossiness in something that is actually obvious because it did it right 10 times in a row, and then it starts to get a bit lossy. But as you can see, it's keeping score in the log. I didn't ask it to do that. But seemingly, it's playing Pong against itself now. So that's cool. And also, I asked it to make us stars in the background and give it clouds. Also very fun. And now you can also just edit it yourself if you can figure out what it did. I mean, it made a swirling plasma. So that's that part. It's also really fun to sort of like live code dive into what the AI has made for you, because it is a creative endeavor, and it is learning how to write these shaders from a place like ShaderToy, which is a creative coding place where people make lots of art. So it is really quite fun to play with the output. But yeah, I hope you can see why maybe doing something similar to what an image generator does for code can do for vibe coding. Because essentially this is what I see as vibe coding. You just chat with the AI, you correct things that it sees. Sometimes you have to get a bit technical. That's kind of not really how you should do it. You shouldn't really tell it how to write exactly the right code. You should go, I don't know, make it wilder or make it shiny, something like that. But yeah, I found that sometimes you do need to get into the nitty-gritty. And the errors, I have not done that yet, but part of the plan is to start feeding back the Rust compiler errors directly into the AI so that it can fix it itself. That is something that you also see people do. It does do that sometimes. I find that if you just paste the errors in, it doesn't always know what to do with that. Maybe it needs more context, or maybe the errors are just a bit, I would say, abstract for it. But often you can just say, hey, you did stuff wrong somewhere over there, could you fix it? And actually that fixes it as well. So, and of course we should now be able to run this on a mobile phone and in WebAssembly. Let's see what it does. Are we going to run on WebAssembly? Oh, it's compiling. Won't take that long though. Are we not going to run on WebAssembly today? Yeah, we are. There we go. Pong in a web browser, ready to be deployed to the world. But I also have something else cool that I was working on, which is mixed reality. MakePad is a UI stack, a UI framework that is essentially very close to the metal of the GPU, very direct, right? Almost no UI structures allow you to write shaders directly. So what I brought here is a Quest. I ported MakePad to the Quest because, one of the dreams that I have with MakePad and is has long been mixed reality or virtual reality, using UIs like this IDE inside VR or inside mixed reality. And the reason that I believe that you need to run these things natively is because if you stream them from a computer to these glasses, it's always going to look kind of grainy or have a lot of lag, and it's just like a virtual TV that is streaming. That is terrible. You need to render the UIs natively on this thing. So I'm going to see if I can start it up. I was actually planning to AI vibe code this, which is a little bit praying to the demo gods. Here we go, Quest. This is what the Quest is seeing. So this is the Quest in mixed reality mode. It is in pass-through right now. Let's see what it does. No devices or emulators found. Oh, right, of course. I need to plug it in. Give me a second. This is also partly because of the work we have done for the build pipeline for Android. The Quest is actually an Android mobile device. And here we go. Building, compiling. Okay, and now, hold on, this is going to require some effort. This is, okay, the frame rate is not going to be super great because it is streaming this, hold on, let me put it like this. It is streaming this somehow, some way to my iPad, which is now streaming that to the computer. But this is my Hello World test application for the Quest. As you can see, it has all the hand tracking information of your hands, and it is emitting particles. You should come if you're interested. If you want to try this out, you should come down when the talk is over, because this does not video at all. Like the thing with mixed reality is that you cannot have an opinion about it really if all you have seen is a video like this. So do try it out. I brought 2 Quests so you can see it yourself. It is also multiplayer. But what is really neat about this new technology is that it has occlusion. And occlusion is a new technology that is available on this device, which means that inside the render stack that I have access to, you have a complete generative, probably lots of AI, depth map of the world. So it knows that there's a staircase there, and it knows that that staircase will clip your geometry, so it doesn't go through it, because that's a very strong immersive breaking moment. Anyway, the frame rate is terrible, so I'm sorry about that. Now I wanted to have the AI generate a new thing. Hold on, let me see. So now I have to look through you can actually reread your screen in mixed reality with this device. It's really quite high resolution. Let's see. Where is my XR UI? And then we have, here's the AI chat that I made. And I said, could you make it a bit bigger? And this is live, so it just did that already. Like I click play and it immediately changes the shaders on the headset. So hold on, I have to, you can't really see that very well. That is the problem with mixed reality, is that it is very hard to share. So I can now live code my the things that are coming from my fingers. But do come down and try this out, because I know this is not at all a good demo of it. But hey, this was this was my stretch goal for this presentation: AI generated mixed reality live coding. So let's see. go back to the slides. So yeah, that is the workflow that I've been exploring. The snapshots, the generative structure. I think it's something that is new and I haven't seen anywhere else yet. So where is this going? You know, what can an IDE do in the times of AI, in the age of AI? I think a very important part that is currently missing in a lot of these applications is that the AI is blind. It cannot see what it made. It cannot see the result. So it has to sort of guess from the code that it generated if it is aligned or pretty. Like if you see here the snapshots of the calculator, like this is also a calculator I asked it to make. Let me see if I can make it bigger. AI UI. Can we load this one? Yeah, so this is also one it made, which is not at all looking as pretty as the others, but it has no real concept of it. You can tell it, but it can only infer it from what you tell it. Whereas this is laid out in such a tight and nice way, it has no feedback of. So I think the next big thing for these models are going to be vision feedback. Vision feedback in testing, so that you can ask the AI, hey, could you click around this application and see if it actually does what you thought it did, and automate that as well. And vision models can also integrate very nicely with sketch generation. So you can sketch up your application and then generate. There's lots of companies that are trying to do that as well. But that is a place where I want to go with MakePad Studio 2. And I think, as I showed you in this presentation, I think it will remain important that you can, as a programmer, as a designer, reach in to the generated code and change it with the tooling that we've had or that we're going to have for MakePad. Manipulating the design, live coding the application, correcting code, and automated UI testing. I think that's going to be a big next step. Also, the use of language models for automatic localization, and you saw that the Rust code generation is pretty good. You can also put errors back into the model, which we have to do. So yeah, that's pretty much my talk. I'll make this a little bit bigger. This is the repository, our website, my Twitter, and yeah.